This video is going to run through scientific notation, which is one specific application of exponents. Scientific notation takes advantage of the fact that powers of 10 work out really nicely, are relatively simple. For example, take a look at the following pattern. 10 squared is 100, 10 cubed is 1,000, 10 to the fourth is 10,000, 10 to the fifth is 100,000. 10 squared has 2 zeros, 10 to the third has 3 zeros, 10 to the fourth has 4 zeros, 10 to the fifth has 5 zeros, etc. And that pattern will work with any power of 10 with a positive exponent. If we have negative exponents, 10 to the negative 1 is 1/10, or 0.1. 10 to the negative 2 is 1 over 10 squared, or 1/100th, 0.01. 10 to the negative 3 is 1 over 1,000, 0.001. There's one digit after the decimal when you have 10 to the negative 1, 2 digits after the decimal with 10 to the negative 2, 3 digits after the decimal with 10 to the negative 3. So using powers of 10 to express either really large numbers or really small numbers can be a very efficient way to describe how big or small a number is. The following three numbers listed on the screen are all written in scientific notation. In scientific notation, we take a number with one digit before the decimal, so the number is going to be smaller than 10 or bigger than or equal to 1. So we take a number times a power of 10. So for example, 3 times 10 to the fourth means we've got 3 times 10,000. 10 to the fourth has 4 zeros after the 1. 3 times 10,000 is 30,000. So 3 times 10 to the fourth is the same as 30,000. Now it turns out there's a slightly faster way of expanding this number, putting this number in standard form. We've got 3 times 10 to the fourth. This 10 to the fourth here is going to take the decimal and it's going to move it to the right 4 places. So the decimal is located after the 3. We move it to the right 1, 2, 3, 4 places and fill those places in with zeros. And that gives me my answer of 30,000. So the power of 10 really just tells you how much to move the decimal. If your 10 has a positive power, we move the decimal to the right because we're talking about a big number. So for example, 5.6 times 10 squared, we can take that decimal, it's a 10 to the positive 2, so remove the decimal to the right 2 units, and that gives me 560. So if our power of 10 has a positive exponent, we're talking about a big number, we're going to move the decimal to the right. If our power of 10 has a negative exponent, we're talking about a small number, and we're going to move our decimal to the left. So 7.31 times 10 to the negative 3, we're going to take that decimal and move it 1, 2, 3 places to the left, and that gives me 0.00731. So that exponent, that power of 10, is giving you information about the magnitude of the number. How many places does this number have? How big or small it is? If we want to go in the opposite direction, if we want to take a number and put it in scientific notation, we're just going to do the opposite. We're going to take the decimal and we're going to move it until there is exactly one non-zero digit to the left of the decimal. So with the number 4,230, I'm going to take the decimal and I'm going to move it so it's between the 4 and the 2. So I have to move it 1, 2, 3 places to the left. Because this is a large number, 4,000, we're going to have a positive exponent. We moved it 3 places, so the exponent is 3, and we can write this number as 4.23 times 10 to the third. Second example, we've got the number 15. We're going to move the decimal so there's exactly one non-zero digit to its left. So this time we only have to move it one place. I move it exactly one place to the left. That gives me 1.5. And since I only moved it one place, it'll be times 10 to the 1. My last one, 3,450,000. I'm going to move the decimal so that's between the 3 and the 4. I want exactly one non-zero digit to its left. So in this case, I have to move the decimal 1, 2, 3, 4, 5, 6 places. And I get 3.45 times 10 to the 6. In all of these problems, I move my decimal to the left. I have large numbers, so my exponent is going to be positive. If we're dealing with small numbers, if we have to move the decimal to the right, that means our exponent is going to be negative. So 0.003, I move the decimal until I have one non-zero digit to its left. So this time I have to move it 3 places to the right, and that gives me a 3 times 10 to the negative 3. 0.027, I'm going to move the decimal 2 places to the right. I've got 2.7 times 10 to the negative 2. So again, scientific notation is used because it gives us a quick way to tell how large or how small a number is. We can also perform operations with numbers in scientific notation by taking advantage of those laws of exponents that we learned about earlier. So for example, if I have the number 4 times 10 to the 5th times 2 times 10 to the 3rd, I can multiply in any order I want. This is really just a product of a bunch of things. So I'm going to take the 4 times the 2, and then I'll take the 10 to the 5th times 10 to the negative 3. 4 times 2 is 8. 10 to the 5th times 10 to the negative 3, that is a situation where we can add the exponents. That's my power rule. 5 plus negative 3 is 2, so I get 10 to the 2. And there's my answer in scientific notation, 8 times 10 to the 2. If we wanted that answer in standard form, that exponent of 2 says move the decimal 2 places to the right, and this becomes 800. Here's another one. 5 times 10 to the 3 times 3 times 10 to the 7. I'm going to take the 5 times 3 first, and then I'll deal with the powers of 10. 5 times 3 is 15. 10 to the 3rd times 10 to the 7th, we add the exponents. That gives me 10 to the 10th. So 15 times 10 to the 10th, is that in scientific notation? It's actually not, because the 15 is too big. We need to make this 15 smaller. We can only have one digit to the left of the decimal in scientific notation. So I'm going to take my decimal, move it one place to the left to make this a 1.5. I just took a number that was big and I made it smaller. So I'm going to make the exponent bigger. That's how I remember it. If you make the number smaller, to balance it out, make the exponent bigger. I move one place, so I'll add 1 to my exponent. I get 1.5 times 10 to the 11th. In standard form, we'd have to take that decimal, move it 11 places to the right, and I get this huge number right here. 15 with, I guess that's 10 zeros after it. We can do division problems in scientific notation as well. 8 times 10 to the negative 2 divided by 2 times 10 to the 5th. I'll do the 8 divided by 2 first, and then deal with the powers of 10. 8 divided by 2 is 4. 10 to the negative 2 divided by 10 to the 5th, we subtract the exponents. Negative 2 minus 5 is negative 7. And so there's my answer in scientific notation. 4 times 10 to the negative 7. If I want the answer in standard form, I have to take that decimal. Because it's a negative exponent, I'll move it 7 places to the left. So 0.000004. Here's another one. 3 times 10 to the 8th divided by 6 times 10 to the 4th. I'll do the 3 times 6 first, and then the powers of 10. 3 divided by 6 is a half, or 0.5. 10 to the 8th divided by 10 to the 4th, I subtract the exponents. 8 minus 4 is 4. I get 10 to the 4th. This answer is technically not in scientific notation because this 0.5 number is too small. Remember, we want exactly one digit that's not 0 in front of that decimal, to the left of the decimal. So this time I'm going to move the decimal one place to the right. I take my 0.5 number and I make it bigger. So I have to make my exponent and make it smaller. So that gives me 5 times 10 to the 3rd. If we want that number in standard form, we have to take the decimal and move it 3 places to the right, and that gives me 5,000. One last thing that I'd like to note is when you're working with calculators, sometimes scientific notation looks a little bit different on a calculator. So if we have the number 5 times 10 to the 3rd, frequently calculators will display that as 5, and then they'll use the letter E and then the 3, and that's just calculator notation for scientific notation. So if you see something on a calculator with this E, this capital E, it usually means the answer is in scientific notation, and that number after the E is the exponent for your scientific notation. All right, that was my last example. As always, please reach out if anything is unclear.